Hello and welcome to this week's What Were They Thinking? This week's news items include a third settlement which puts a doctor on probation, yet again, for vaccine misinformation and mishandling, the continuing drama of the first effective malaria vaccine and its lack of uptake in Africa, particularly by governments, an example of natural selection in radiation-prone areas around Chernobyl as demonstrated by frogs, the bizarre development of a brain cell culture that can play pong. The Associated Press has issued a publication around the disproven, or at least widely debunked, Seralini study that claimed genetically modified corn, and for that matter glyphosate, had negative effects on the health of rats involved. There's also a further step on the way to understand how protons move through water. The timestamps for these and other news items can be found in the description box below. Starting with medical news and the settlement with the medical board as to Dr. Bob Sears' behaviour. The medical board has decided to agree to a settlement. The settlement puts Dr. Sears under probation until June 2023. In the meantime, they're required to undergo a number of medical courses. This is a very light penalty considering it is the third instance in which they have been put under probation. A third error, the same kind of error, and yet behaviour has not changed. Clearly, they're not learning their lesson. The gist of their position is that they are an anti-vaxxer. They work to generate fear and unrest about vaccine safety, something that has been demonstrated repeatedly. The problem is that they're not just generating fear, they're profiting from that fear. And this is one situation in which it's not just an expression of concern or welfare, it's a selfish, self-serving expression of fear. The general reason why he's been punished and how it relates to vaccines is that the doctor was issuing exemptions, that is, medical exemptions as a reason not to be vaccinated. In some cases, there are valid reasons to be exempted, for example, extreme immunological reactions or adverse reactions to prior vaccinations. It's a good reason not to take an unwarranted risk when you know you are predisposed to having something go wrong. However, that's not the general means by which this doctor has been basing their exemption criteria. Rather, as the third lawsuit presents, they were given an exemption based on a second cousin having had a severe vaccine reaction with developmental regression and eventual diagnosis of autism. The problem is vaccines don't cause autism, and developmental regression is generally a part and parcel of autism in some cases. It depends on where they lie on the spectrum. So it's a second cousin, so not directly related in those terms. It's apparently from vaccines, and apparently they caused autism. Yeah. At best, this was a thin string, but the conclusion is utter nonsense, and so the exemption should have also been denied. Why they've chosen to take such a lenient approach to the doctor, despite having repeatedly shown not only a failure to act, but a failure to learn from prior punishment, is a problem, and one that we can't explain. Going from vaccine exemption news to good vaccine news, but also with its own dark cloud, the malaria vaccine we've spoken about several times over the last few months has basically been approved in Africa. It's not a perfect cure or preventative treatment, but it's certainly better than letting hundreds, if not thousands, of children die every year from an avoidable condition. Despite a very clear-cut and very obvious benefit, a lot of the governments in Africa are not getting on board. They are not choosing to buy the vaccine and deploy it, and the major argument so far has been that it lacks cost-effectiveness. That is, it's too expensive and provides too little benefit. We disagree with that argument, but we can't argue with their other consideration, which is logistics. Many of the governments argue that it is too challenging to distribute the vaccine across everywhere it would have to go to provide effective treatment, especially going forward into the future once the pool of individuals to be vaccinated, say in major cities, runs dry. Most governments in Africa seem to be more willing to opt for cheaper and arguably less effective options, such as insecticide-treated malaria netting. The problem is that the vaccines themselves, along with these interventions, seem to provide an even better result. Then, of course, the fact that many individuals don't end up using the more passive defensive mechanisms like netting. Rather, they simply live with their condition. As the article linked below explains, if you were to look at somewhere like Nigeria, a country with about 31 million children under 5 years of age, more than 130,000 of these would be saved from death if you were to vaccinate them and provide netting. That's because more than 130,000 children die due to malaria each year. That, of course, assumes a near perfect outcome. Unfortunately, reality rarely plays that nice, and it's going to be closer to half that figure at about 65,000 children each year saved. Still, that is a lot of avoidable children dying. In an example of the world being, reality, and compensating for how reality is rarely so nice, we can go to Chernobyl, and the fact that the radiation coming out of there is having an effect on the local fauna and flora, notably frogs. The frogs are compensating for this new radiation by darkening over time. The frogs have turned nearly black. This is a much darker appearance than their similarly positioned comrades that are near yellow, but outside the radiation-blasted ecosystem. This is an example of evolution. Adaptation to an environment where the darker your skin is, the better you can survive, because the darker skin avoids as much of the radiation's impact as lighter skin does. Humans alone have exhibited this, with those living in Africa, and particularly the Saharan Africa, being much darker skinned than those who live in the extreme northern climes of the world, the Nords for instance, who are generally always light of skin and light of hair. Humans have developed the same pattern of response for exactly the same reason the frogs have. That is, it minimizes the radiation damage to DNA. This means it lives longer, either as a human or a frog, and from there they can therefore pass on their genes and you get the trait being spread. Another way to spread traits is admittedly far more bizarre, and that is by splicing tissue into another species. And scientists have done this by taking human brain tissue and putting it into the brains of rats. The idea here is that by effectively transplanting stem cells, you could help to address neuropsychiatric disorders or brain damage. At least in theory. Understand, this is early work, but the proof of concept is there, at least with regards to the transplant of cells. The other benefit to this that isn't necessarily obvious on the surface is that by transplanting brain tissue from a human to an animal model, you're able to recreate uniquely human psychiatric disorders. Think of things like schizophrenia and autism. These are almost undiagnosable and unidentifiable in animals. Because of this, you can create a quasi-human demonstration of these conditions by literally putting parts of a human brain into the animal. The catch with that approach is that you can't transplant parts of a developed brain organoid, effectively synthetic brains, into a fully developed rat. You just don't get the neural connections that are needed for it to be able to do what has to be done. Instead, what they've done in this study is that they've taken the stem cells that will give rise to the human brain organoid and put it into rats that were still growing. This meant that the brain organoid, that's human, would grow at the same time as the rat's brain would grow, and the two could, to an extent, mesh together and become fully functional and almost symbiotic in nature. That isn't the only brain cell culture related news we have for you this week. There's also an experiment trying to figure out if you could grow a brain organoid, or at least organoid-like structure, in a petri dish or cell culture dish, and then allow it to play games. in this case pong. They found that once you had reached about 800,000 neurons, you were able to start teaching it to play games, and as mentioned, this is pong in particular. It doesn't necessarily mean they're very good at it, or that they would perform it for very long, but they can perform a given task. This is uncomfortably very similar to what a server from 40K might do. The setup is surprisingly simple, but also difficult to do. It's made up of two kinds of sets of neurons, some from embryonic mice and some from humans. They were then grown on an array that had small electrodes underneath. These could be turned on and they would stimulate the neuron. This was the sensory input. The output would then come back and it would tell the game what to do in response. By having the electrodes on either one side or the other of the dish activated, it could tell where the ball was in the game and would then allow it to respond. And this was its thinking process. The cultured brain by itself could not just learn though. It needed to be coupled with a program that would help to teach it. And this is what allowed it to get better at playing pong. And in fact, it was able to figure out what to do in about 5 minutes. The weird thing here is that because of what this is, remembering it is just cultured cells in a setup where it gets stimulated to know that something is coming in and to respond to it, there is no reward for what it does. As a result, what it's learning is almost a development. It's not a behavior, it's a self-organization method. And because you can't punish it either, you can't prevent it from making mistakes, which means it can only learn based on what works. Going back to animal news briefly, but this time wild animals, and it's the discovery of a disturbingly large cockroach. The large cockroach is from Australia and hasn't been seen in the wild for about 80 years. The giant creature was found on an isolated island off of the east coast of Australia. Unfortunately, when an introduced species, primarily rats, found their way to the island on which it lived, the rats basically decimated the population, and it hasn't been seen since. It was thought to have gone extinct, but apparently some of them figured out how to survive. Next we have an article which is more a rehash of old news, in fact news that we've been over ourselves before, and that is the claims that the Seralini study showed that genetically modified corn, and for that matter glyphosate, led to cancer in rats. Reality is very different from these claims, unfortunately, and that reality is also what bit the study hard. It's why it was first retracted from the first journal in which it was published. It was retracted at the time because it was not the appropriate venue to publish it in, but also because just about every academic worth their salt happened to criticize it so extensively that it really couldn't stand on its own merit. It was later republished in another journal, under the very careful caveat that it was not to be taken necessarily at face value, but simply contributing to the body of research available. This has not prevented it from being shared extensively on social media. The social media sharing is done without any critical thinking, and so without that, people would just take what is said at face value, and that face value is, well, not worth it, as we've mentioned. It's worth noting that we have provided a link, both in the description below and in the top right, to a series of videos we've done on the safety of genetically modified foods and the safety of glyphosate, both of which were points of contention in the Seralini study. Primary takeaway message from these videos is that genetically modified food is safe, and that it has shown absolutely no demerits compared to either conventional crops or organically grown crops. That glyphosate is safe, and that just about all research to date has shown that there is no negative effect from it. There is also the matter of that lawsuit, which was a civil proceeding, and therefore decided by a jury, not necessarily on any knowledge or understanding of the science of what glyphosate does. The final news item we have for you this week is about physics and the movement of protons through water. In water, protons behave weirdly, particularly if you have an electric field there. This was known as far back as the start of the 19th century, where Theodore Gotthaus put forward a hypothesis. This leads to today, so more than 200 years later. The most recent findings appear to show that 3 water molecules work in tandem to build a sort of moving mechanism, a vehicle to carry the proton as it goes through the water. As it lays down one of the water molecules, the one at the back is pulled up and it gets laid down eventually at the front as well, and this continues to be recreated as it moves through the water. While this research isn't going to lead to any major discoveries in its own right, after all, water behaves weirdly at the best of times, and knowing more about that is nice. It's what it translates to beyond water that will be relevant. Think of things like cellular respiration or photovoltaic energy, solar panels. All of these could be impacted by the discovery of how the molecules move and carry with them that proton. That's all the news we have for you this week. Thank you for watching. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.